Okay, so this is Pre-E4.1, which is Exponent Rules. We're fixing to get into graphing exponential functions. So before we start dealing with exponential functions, I just wanted to review some of the exponent rules that we might be using. Okay, so the first one is any base raised to a power times another base that is the same base raised to another power. If we have like bases, we can add the powers. So in other words, if I have something, I'll just put for example, if I have something like x to the 4th power times x to the 6th power, okay, as long as the bases are the same, then here we can add the bases and get x to the 10th power. Okay, remember this is just like our normal FOIL or distribute that we've done before. Another example, if we had something like x squared times, I don't know, x to the 7th plus x to the 3rd, something like that. Okay, notice whenever we distribute here, we would add the exponents, right? That's because I have the same base being multiplied, so I would add the exponent. So here we get x to the 9th plus, when I distribute here, I get x to the 5th. Okay, so when you're multiplying and the bases are the same, we add the exponents. Okay. The next one is kind of an extension of that. If we're dividing, then we subtract the exponents. So for example, if I had 2 to the 4th power over 2 squared, okay, I could just write this as 2 to the 4 minus 2, which is 2 squared. Okay, which then we would go ahead and simplify and say this is 4. And this makes sense. You don't have to write this part, but really this is saying we have 4 copies of a 2 over 2 copies of a 2. So notice we would be able to reduce 2 of them, and we would end up with those 2 copies. Okay. The same is true if you're reducing, subtracting, and the larger one's on the top. Okay, so if we had something like x to the 3rd over x to the 6th, okay, I could think about this as 3 x's on top and 6 x's on bottom, and then reduce 3 from top and bottom, right, which would leave me 1 over x cubed. Or I can think about subtracting, okay, whichever one you move is the one you subtract. So here I could move this x to the 6th up to the top and make it a minus 6, or I could move this x to the 3rd down and make it a minus 3, okay, which is what I would choose to do in this case. So I would be left with 1 over x to the 6th. If I move that one down, okay, I can just subtract it, which gives me 1 over x to the 3rd. Okay. So this draws us to our next rule. Our next rule is that anytime you have a negative exponent, all you have to do is move it across the fraction line in order to change the sign of the exponent. So here if I have x to the negative n, notice I would move this whole base down to the denominator, which would then make it 1 over x to the positive n. The same thing is true if you have a negative exponent in the bottom. If you have 1 over x to the negative 3, okay, you can then move this up like we talked about in the last example to get x to the positive 3. So basically, anytime you move an exponential across the fraction line, it changes the sign of the exponent. Okay, and that will help us out because we always want to end up with all of our x's in one spot or all of our y's in one spot and that kind of thing. So if you have x's on top and bottom, you want to collect them all in the same place, and we do that by moving them across the fraction line, which now we know changes the sign of their exponent. What's this? Okay, the next one is when we have an exponential base raised to a power. Okay, so notice if we only have just one base here, it's not like that first rule. Here we just have 1x, right? And it already has an exponent on it, and then we're raising it to another power. Anytime you have a power raised to a power, we multiply the powers. Okay. So this would be something like x squared, I don't know, raised to the 7th. In this case, I would multiply those and get x to the 14th. Okay. And then this next rule is just an extension, saying that if we have a power that is around an entire fraction, we have to distribute that power to the base in the numerator and the base in the denominator, regardless of how many bases there are. So in other words, inside here, this is like x to the first, y to the first, and I'm distributing the n to their exponents, which would give me x to the n over y to the n. Another example would be something like, I don't know, 4x over y squared, something like that, okay? I would have to distribute this squared to every single base in that quantity. So that means 4, this is like to the first power. I have 1x, so x is to the first power, and then my y is squared. So I would distribute this 2 to every single exponential or exponent of every base within that quantity. So this would give me 4 squared x squared all over y to the fourth. Again, because it's raised to a power, I multiply exponents. And then I just multiply the number part out. So this would give me 16x squared over y to the fourth. Okay. So now that we know our rules, we know when to add the exponents, when to multiply the exponents, and how to get rid of negative exponents, now we're going to put them all together and look at some examples. Okay. So notice in our instructions it says to write with positive exponents only. It's very important in my math lab. It won't let you enter negative exponents. So in this case, I want to simplify my numbers as much as possible. Okay, they're both divisible by 2. So 4 goes into 2 2 times. 2 goes into 6 3 times. So my numbers just become 2/3. And then I want to combine my x's into one spot and my y's into one location. Okay, so I'm going to do them separately. I'm going to look first at just my x's. Notice on top I have an x to the first power, and on bottom I have x to the -1 power. So I want to combine those into one area. So I'm going to have to move one of them across the fraction line. Now you can do it either way, but it saves you time if you move them to where the exponents will be positive. So notice if I took this top one and moved it down, that would make it x to the -1, right? And then this x to the -1 and that x to the -1 would make this x to the -2. So I really don't want to be left with a negative. So instead of moving the top one down, I'm going to move this bottom one up. Because if I move the bottom one up, then I end up with x to the +1. Okay? So I have the x to the +1 that's already there. When I move the x from the denominator up, it becomes x to the +1. And then I can combine those. Okay? Before I do that, I'm going to look at the y's. When I look at the y's, I have a y to the -3 on top and a y to the first power on bottom. So again, if I move this y up, I'm going to get y to the -1. Combined with the y to the -3 would give me a negative number. So I'm instead going to move the top y down. If I move it down, that would give me y to the +3. So now I have the y that was already in the denominator, and now the y to the +3 that I got from moving the numerator y down. And now I can just go ahead and combine these. So I have 2x and x. Again, remember, if their bases are the same, you add their exponents. This gives me x squared all over 3y to the 4th. Okay, not too bad. Let's look at another one. This one, same thing. I'm just multiplying. When I multiply, here, notice this, you can write it with a dot or you can write it with parentheses. This would be the same as doing like x times 2x. Okay, we just multiply the number parts, which would give us 2. We multiply the x parts, which would give us x squared. This is the exact same type of thing, except we have several variables. Okay, we still just multiply the number part, so -3 and 4 give me -12. And then I multiply the x's. Okay, here if I multiply the x's, I have x to the 4th times x to the -2. And if I multiply those, notice I have the same base, so I add their exponents. So that's going to give me x to the +2. Now I do the same thing with the y's. So I have a y to the first power and a y to the -3. When I combine those, notice when you just have a y, it's an implied 1 on your exponent. So 1 and -3 combine to give us y to the -2. So I'm going to go ahead and just write out what we have so far. So I have -12 x squared y to the -2. And then remember, our instructions said that we have to write our answer with positive exponents only. So here my fraction line, notice, is under here because I don't really have a fraction. And then I need to move the base that has the negative exponent across the fraction line, which means I need to move my y to the negative 2 down so that it will become y to the positive 2. And I still have negative 12x squared on top. Okay, let's look at a few more. So the next one, I'm implementing the power rule. Okay, power means I have to distribute that exponent to every exponent on each base within this quantity. So notice that's like I'm going to rewrite this. This is the same as 4 to the first power all over 7 to the first power and x to the first power. And I'm raising that to the negative 2. So I'm going to distribute that negative 2 to everyone's exponent. So this gives me 4 to the negative 2 all over 7 to the negative 2 times x to the negative 2. And then anything that has a negative exponent, which in this case is everything, right? I move it across the fraction line. So that means the entire denominator gets moved up, the entire numerator gets moved down. So this guy's going down, and these two guys are going up. So I end up with 7 squared x squared on top and 4 squared on bottom. And then I can go ahead and multiply out the number part. So I get 49x squared all over 16. Okay, not too bad. Okay, and I do want to point out one thing. We may do it this way on the other way. Notice since this whole thing had a negative exponent, that negative, remember, moves it across the division line. So if my whole fraction has a negative exponent, that means the bottom's going to end up going to the top, and the top's going to end up going to the bottom. So another way to work this one is we could take that negative exponent and just go ahead and flip it. So that would give us 7x over 4 to the positive 2. And then from here we could work it out to get 49x squared all over 16 by squaring each base. Okay. So either way is fine with me. If you'd like to take the negative and use it to flip the whole thing first and then distribute, or if you'd rather distribute and then move the negative exponent bases, that's fine. Okay. Let's get another one. This one's the same idea, so we can work it either way. We can flip it first or distribute it. I'm going to go ahead and distribute it, and then I'll show it the other way also. So this is the same as 2 to the first power, x to the first power, all over y squared, raised to the negative 1. And then I distribute that negative 1 to each base's exponent, which will give me 2 to the negative 1, x to the negative 1, and y to the, notice we already had a number here. We had a y squared. When you have a number squared raised to another, we multiply. So 2 times negative 1 gives me negative 2. And then again, everything has a negative exponent, so the bottom goes up, and the 2 items in the numerator go down. So I end up with y squared on top. On bottom, I end up with 2 to the first power and x to the first power. And I'll show it works out the other way. If I flip this one first, if I see the negative exponent, I can go ahead and flip it and get y squared over 2x, and then just raise it to the first power, which in this case, anything to the first power is just itself. This would just be y squared over 2x. Okay. So either way, notice you do get the same thing. Okay. Let me look at a couple more. Let's say a couple more. Maybe no, just one more. Let me look at one more. Alright, so on this one, again, same thing. I can distribute this 3, and now notice it doesn't have a negative, so there's no flipping here. But I do want to point out, I have x's on top and bottom, and I have y's on top and bottom. So what I'm going to do is I'm going to simplify the inside first. Okay. And the reason I'm doing that is that just makes it less to distribute that power to. So if I look at my x's, notice for my x's, I'm going to move my bottom x up. When I move my bottom x up, that leaves me with an x to the 7th that I already had on top. And when I move x to the 4th across the fraction line, it becomes x to the negative 4th. Okay. Then I want to do the same thing with my y's. To determine which way to move my y's, I want to figure out where is it going to leave my exponent positive. So if I move my bottom y to the top, it will become negative 6, which is going to leave me with 3 minus 6 is negative 3, so I don't want that one. So I'm going to take my top y, y cubed, and move that down. So I have y to the 6th that's already there. When I move my y cubed down, it becomes y to the negative 3. Okay. Then I can go ahead and combine and then worry about that cube. So x to the 7th times x to the negative 4 gives me x cubed. Y to the 6th times y to the negative 3 gives me y cubed. And then that whole thing is cubed. So to cube the entire thing, I distribute that cube to both bases exponent, which leaves me with x to the 9th over y to the 9th. Okay, so that's the end of pre-E1. I'll look here. So you should now be able to complete the pre-E1 assignment, which is a MyMathLab assignment. There's no worksheet that goes with this. However, you can complete the couple extra pages that goes along with this if you want extra practice. If you have any questions, let me know.